Good morning. Thank you for having me. I'm Lee Ferguson. I'm going to talk to you guys today about some work that we've been doing over the last year to understand the impacts of extreme storm events and specifically Hurricane Florence on water quality issues in eastern North Carolina. As we all know, Hurricane Florence spread awful lot of misery across eastern North Carolina. So we were really afraid, when we saw the peak of this storm, 140 miles per hour, Category 4, ended up making landfall near Wrightsville Beach as a Category 1. But the problem is that it was moving so slow, it essentially just parked itself over eastern North Carolina and drenched the place for days. So the combined rain and storm surge, it was really the wettest hurricane on record in the Carolinas. And so for somebody who studies water quality impacts, this really brought up the question of what happens to pollutants in the water when these kinds of extreme events that are hard to plan for actually happen. So we really kind of took a deep dive into this. And so as you see, the rainfall from Florence was really concentrated right there in sort of southeastern North Carolina. And you could see that at its peak, the winds, reached somewhere around, 30 to 35 miles per hour in Jacksonville. But what really happened is between September 14th and September 17th, so just in the space of a few days, we had 30 inches of rain in Jacksonville. And you can see that this wasn't just isolated to a specific area. It was all along the eastern coast of North Carolina. And together with the rain, we also had storm surge. So you had this scenario where the coast of North Carolina, and especially the river basins, the Cape Fear and the Neuse river basins, were just sort of squeezed from both ends. 30 inches of rain from above, and then the storm surge coming in from the east really led to a lot of areas that had not been flooded for many, many years suddenly experiencing major flooding. You can see that in these slides. Here is just a snapshot of the Neuse Basin. You can see New Bern, Trenton, Pollocksville. This is essentially a blow up of the Trent River area. And so this is what it looks like under normal conditions, a lot of farmland. And then after Hurricane Florence, you can see all the dark area here around Trenton and Pollocksville is essentially water. Okay, so that's all flooding. And so the Trent River overflowed its banks and inundated bridges, homes, farmland, all of these areas that contain both sort of consumer chemicals, agrochemicals, and in some cases industrial chemicals that were now, as Reich said, exposed to water where, in cases where it usually doesn't happen. So what we did is essentially take a sampling trip down both the Cape Fear Basin as well as the Neuse Basin and take a look at some of these impacts. And as you can see, really, there were a lot of areas that were flooded here. Just some pictures of this is, I think, Goldsboro, some gas stations and other types of areas. Industrial sites you can see down here on the right. These aren't just Superfund sites. Wright mentioned the hazard that might come from inundation of CERCLA regulated Superfund sites, but even just normal industrial sites that aren't considered hazardous waste sites under normal conditions, when they're inundated with flooding, you can have release of contaminants from just normal operations. And that was what we were concerned about, and that's what we could see in certain cases here. So in addition to sort of the misery from sort of the flooding itself, you also have the potential for pollutant release. So what happens to all this water once it inundates these areas with flooding? Runs off into the rivers, and then eventually the rivers reach the ocean. And so what you can see here is a satellite image after Florence. You can see these where the rivers had overtopped their banks and towns flooded down into the coastal area, and you can see these plumes of, this is what's called CDOM, colored dissolved organic matter. Okay, some of this may be hog lagoon waste. Lots of it is natural organic matter that has been flushed out of the soils, the agricultural areas, the forests, and so it causes, as you can see, visible water quality impacts in the coastal area. And it also gives you a scale for just how much material was actually released during these flooding events. And so this was not just a problem along the coast, also up around the Cape Fear River as far west as Fayetteville and even farther. Bridges were closed because of flooding. At one point, all the river crossings east of I-95 were closed, and so it was actually hard to get relief into the area. And some of these areas were flooded for almost 2 weeks. So it lasted a long time. We were interested in studying water pollution along these areas. So we went out and sampled all the way from Raleigh on the Neuse River, all the way down along the Neuse, the Trent River, all the way down to near Havelock in the estuarine area of the Trent estuary. And then we also had a team that tried to make a trip down the entire Cape Fear. You can see that these CF sites, those are Cape Fear sites. You can see we have a cluster of them up close to Fayetteville, and we have another cluster down in Wilmington. What happened to the area in between? Well, that area was completely inaccessible, so we just couldn't get there to actually get those samples. We did some good planning and were able to get to most of the areas along the Neuse, but it was actually difficult to get some of the to some of these because of the bridge closures. So when did we sample? We actually sampled at 2 time points. We sampled at the height of the flooding on September 19th. You could see that this plot here is the USGS stream gauge on the Neuse in Kinston. And so you could see that we sampled right at the height of the flooding, about 25 feet over essentially flood stage or above normal. And then we also came back about a month later once the flooding had ebbed and tried to get a picture of what normal looked like in the Neuse estuary especially. So we sampled everywhere from banks of rivers on the left. That's actually Raleigh. It actually looked pretty normal even during the September 18th sampling. New Bern, North Carolina, we were able to sample off of bridges. In the background, you can see the sailboats with their masts torn off and the docks sunk. And in some cases, here's my lab manager, Abby, sampling in Pollocksville. We couldn't even approach the river. So we basically pulled up to the edge of the floodwaters and waded in as far as we could. We could just barely see the tops of houses sticking out above the floodwater, and we could see where the river was, but we couldn't get to it. And so we took all these samples, we took them back to the laboratory, and what my laboratory specializes in is analyzing environmental organic pollutants. So the kinds of things that could be present as pesticides, as wastewater-derived organic contaminants, industrial chemicals, really spans the gamut. This is what the data looks like. This is what's called a heat map. Every column is a sample. Every row is a compound, an individual molecule. So we do what's called non-targeted analysis with instrumentation known as mass spectrometers in my lab. When we took all of these samples from the Cape Fear as well as the Neuse from during flooding as well as a month after, we put it all together. We end up with about 2,300 compounds that we were able to discern in the samples. So lots of molecules. So of these, we were able to assign high confidence identity to about 640 of them. Okay, so what are the rest of them? We're still working on that. Okay, that's actually the details of what we do in the lab. So what you can see here is that the blue indicates intense, high intensity peaks. The red is low intensity. And so from this picture, what do you get a sense of? Well, what you should take away is that the compound profiles in these samples were highly variable. Okay, so they weren't constant across all the different samples, and it really depended on the flood stage that we sampled at as well as the location. And so when we kind of tried to distill this down to ask the questions, what was different between flood stage versus normal stage in these rivers, we could produce something called a volcano plot. So everything in red over here, in that red box, is significantly higher during flooding, okay, in the Neuse River in this case, and everything in the green box was significantly higher during normal stage. So what are some of these compounds? Well, in the flooding area, you can see a couple of molecules, scopoletin and nobiletin. These are actually natural products. These are things that come from trees or plants or soil. And so what's happening here is you're getting washout of those materials by inundation of agricultural or natural areas. And then you have things like benzothiazole. That compound is actually used as a vulcanization accelerant in rubber. So this is stormwater. Right, just like Reich said, okay? So you're seeing indications of stormwater-derived contaminants coming into these areas. Now, we also had compounds that were higher during normal conditions. So what are these? Well, you have things like atrazine metabolites and simazine metabolites. These are agrochemicals. Atrazine is the most widely used herbicide in the United States. Why is it higher during the normal conditions and during the flood conditions? Dilution. Right? Dilution is the solution to pollution, right? So this is a good example of that. And then we notice this other compound, fluoridone. Now, what is that? There's a whole story behind that, but fluoridone is one of these compounds that I never see in my analyses. If there's anybody here from DEQ, you might recognize this compound. It was actually permitted to be used in the Eno River to control hydrilla. I didn't know this until I started Googling, what is fluoridone doing in North Carolina? It's a registered aquatic herbicide that's used in ornamental ponds. So what in the world is it doing in the Neuse River? Well, it turns out it was used at such high amounts in the Eno River. It's making its way all the way down through the Falls Lake Reservoir into the Neuse River, and we can see it as far east as New Bern. So this compound has definitely made its way from the Eno to the rest of that watershed. Well, here's a great example of a tracer that can tell us where pollution might be coming from. This is a compound known as sucralose. Does anybody know what that is? Splenda, right? If you like to drink Splenda in your coffee, well, so Splenda is a low-calorie sweetener, which means that we don't metabolize it. Turns out that wastewater treatment plants also don't metabolize it. So it goes right through you and then right through the wastewater treatment plant and directly into the rivers. And so at the top plot here is actually from the normal conditions in October after the flood stage diminished. And you can see that the sucralose concentrations in the Neuse River decline as we go away from Raleigh, right? Okay, that makes some sense because more people live in Raleigh than they do down in New Bern, right? So you have this sort of dilution curve, right? And then you see a big drop off at Havelock. Well, that's just dilution from the ocean water, right? So if you plot this versus salinity, it's actually a beautiful curve. So what's happening down here during the hurricane flooding? Well, if you just concentrate on those end sites, first of all, the Cape Fear River didn't have an awful lot of wastewater impact during the hurricane. Okay, that actually makes a little bit of sense. But what's happening here in the Neuse River? You can see that the intensities for most of the sites are much lower than during the normal flood condition stage, and that is again due to dilution. But there's this one spot right between N2 and N3. Where is that? That's actually up around Smithfield. So where you see this increase in sucralose between those two sites and then it declines. So the question is, what happened there between N2 and N3 that caused that spike in sucralose? So when I went back, it turns out that Johnston County had a release of about 100,000 gallons of untreated wastewater in its wastewater treatment plant. Okay, we saw evidence for that directly in our analytical chemistry. And this goes back to exactly what Reich said. We didn't actually coordinate these presentations, but he set me up perfectly for this. Wastewater treatment plants that are built in floodplains are probably not the greatest plan for resilience in hurricane storms, right? Because in this case, you're getting washout of untreated wastewater essentially into the rivers. You guys have probably heard about GenX, right? So GenX is the perfluorinated chemical family that was produced by and still is produced by the Chemours company near Fayetteville at the Chemours works. These chemicals are used to make all kinds of things, including Teflon, stain-resistant coatings, etc. So they've been found as, at relatively high concentrations, especially over the last few years in the Wilmington drinking water because of inadvertent releases from the Cape Fear plant at Chemours. They're related to what we call legacy perfluorinated chemicals. These are what we call forever chemicals. They never degrade under normal environmental conditions. I always say they're going to be around when the sun goes supernova, right? So it's probably not the greatest thing to be putting in our drinking water. Turns out when we looked in our samples, especially from the Cape Fear River, during the flooding, you see that you have this spike in bars right there at the CF3 site. That is directly downstream of the Chemours plant. All of these compounds are related to GenX. So GenX is the little red bar, and then we've got all these other compounds that are industrial byproducts that are made by Chemours. Now this sampling was done long after Chemours stopped discharging their industrial waste into the river. right? So why are these compounds showing up in the river during the flooding from Hurricane Florence? Well, it turns out that the groundwater around the site is extensively contaminated with these chemicals. It's essentially made that site into a generator column for these compounds. And when you have flooding and inundation, this goes back to the issues around Superfund sites and contaminated sites. It can inundate and wash out those compounds into the rivers. We also saw indication of what we call legacy perfluorinated chemicals. In this case, during normal conditions, you see a spike of these compounds. These are perfluorosulfonates down around site N9, which is down at Havelock. We've actually gone back in the last month to try to figure out where this was coming from. Turns out it looks like it's coming from the Marine Corps Air Station there. They use these compounds as firefighting foams. So we've verified that that seems to be the source for these compounds in that area. We certainly know that Hurricane Florence caused a lot of flooding in eastern North Carolina. When we go back and we do chemical analysis, we can get hints of where these individual compounds that I'm reporting to you are coming from. We can diagnose sources of pollution into these floodwaters, things like industrial discharges, municipal wastewater, in some cases stormwater contaminants that are releasing signatures into the waters. We found things like pesticides and legacy perfluorinated chemicals in the water, but typically they were at lower levels during the storm, and this is because of the dilution factor, right? And then we saw hints of these emerging perfluorinated chemicals in the Cape Fear River, likely due to releases from the Chemours plant. So with that, thank you, and I'll thank the North Carolina Policy Collaboratory for actually funding this study, as well as all my colleagues. So thanks.